let's talk about, all right, chapter 6, the integumentary system, okay, our skin. Okay, this is the largest organ in your body, okay, and we're going to talk about, or obviously the skin, and the fact that one, it's a cutaneous membrane. We talked about the 4 different membranes in chapter 5, and so we're going to talk about the skin, and then all the, what we call the accessory tissue, the other tissues that are involved, like glandular tissue, hair, nails, all right, and even some of the smooth muscle. There's only one smooth muscle tissue, that's the erector pili muscle. So it's really not going to be too much outside of what you haven't learned already. I can almost guarantee you, and again, I can't say this for everybody because it's a test bank, but you'll see this. All right, it'll ask you another name for the skin. All right, for the integument, I should say. Okay, and that's going to be the cutaneous membrane. All right. So as you know, and I mean, you don't have to read the book to figure this out, but you know that your skin or the cutaneous membrane is going to create a barrier between the underlying organs, all right, and the outside world, the external environment, bacteria, viruses, different types of pathogen, ultraviolet radiation. Your skin protects the underlying organs, mainly skeletal muscle tissue, but there's connective tissue under there too, and then some of the other organs, some of the digestive organs. So keep that in mind. So it really is a barrier that separates the outside world from everything inside your body. And in fact, when you get into the immune system, which is in chapter 21 or 22, it's considered to be part of the innate immune system. Okay? The innate immune system is just exactly what this is. It's a physical barrier. It keeps bacteria from penetrating into the more sensitive organs and tissues in your body. I use it all the time as a visual indicator there of somebody's health. And if you see somebody and they have yellowish skin, like, what are you thinking? What about babies when they have yellow skin? What do you think? Jaundice. Yeah, jaundice. And jaundice is an actual medical condition that we give to people or babies, all right, when you get a breakdown of the hemoglobin molecule. The hemoglobin molecule is a protein molecule that carries oxygen. And when you break it down, it happens in the spleen and in the liver. When you start to break it down, one of the intermediate products of hemoglobin breakdown is bilirubin. If you have a lot of it, it can deposit in the skin, and it gives the skin a yellowish tint. The sclera of your eyeballs, all right, will have a yellowish tint. And then that is going to lead you, most of the time it leads people to bleed the liver, because it's mainly the liver, all right, during that process of breaking down bilirubin, but the spleen also, okay? So you can use it to help, all right? If somebody has blue skin, what are you thinking? Not like Blue Man Blue, but you know what I mean? But blue skin, what are you thinking? Lack of oxygen. Cyanosis. Yeah, you're going to think, okay, hey, wait, there's a problem here. They're not getting enough oxygen, all right? Like their lips turn blue. You're thinking, all right, they're either really cold, but usually it's an indication of they have decreased oxygen, okay, in the blood. Okay, so big study area here is dermatology. In fact, I mean, the doctor, at one point, I don't know if it's still true, but I have a feeling it is, that dermatology is still the most difficult specialty to get into if you're going to be a doctor. Okay? I know at one point you needed the highest board scores. Most dermatologists have I don't want to say it's a cush job, it's really nice. It's like 9 to 5. I don't know too many dermatologists that are working ER hours, okay? But it is really, it's a tough specialty to get into, but that is the study of the skin here. Okay, so some of the functions, and we talked about this before, and I talked about it on the previous slide, it acts as a physical barrier, okay? So it keeps out a lot of the bugs, the microbes there, all right? Bacteria, viruses, and whatnot. Harmful substances just in general, all right? You spill something, you know, bleach is a relatively harmful substance if you were to get it onto sensitive structures in your body. All right, it's an awesome product to kill off microbes and whatnot. All right, but if the skin will protect you, all right, if you're messing around, especially with harmful substances, chemicals and whatnot, it will help to protect you from that. Extreme temperatures, of course, because it does help to keep heat in. Okay, in cold temperatures, and when it gets really hot, it helps to release heat from your body. Okay? Ultraviolet radiation, we saw that with the melanocytes. All right, they make melanin, which is that awesome product that protects the DNA inside your nucleus. Okay? It coats the DNA, and the cells that make melanin will share it with their neighboring cells. Okay? All right, so dehydration, it helps to prevent dehydration. Right? Helps to prevent loss of water in considerable amounts, and it helps to prevent actual too much water being taken in. You can actually have too much water. There was a radio contest, this was years ago, in which they challenged contestants to drink water. I can't remember how they did it, but if you won, you were going to get like an Xbox. This is an Xbox way back before they had the Xbox 360 or the Xbox, or maybe it was a PlayStation. Anyway, it was a big contest. Well, these contestants, there was a contestant that drank too much water in that period of time and actually died. I cannot remember the exact situation in which would have happened if it caused shutdown of the kidneys and whatnot, but they had an issue and they unfortunately ingested too much water. Point being is, all right, our skin is not waterproof, and I mentioned this before, it's water resistant, okay? So it's not a perfect barrier against water. All right, we'll talk more about vitamin D3, all right, but it's called calcitriol, but that's where it starts to get synthesized in our skin. That's why, you know, you'll have people saying, oh, you could take this vitamin D supplement, it's 5,000 IUs, you should take this daily. First of all, I'm going to tell you something about vitamin D. You need to know if you're deficient in it to begin with. All right, the only way to do that is to get tested for it. All right, I didn't think I was. I thought I was pretty good, but I went and got my blood drawn and had vitamin D, and I'm clinically deficient in it, so I take about 5,000 IUs. Again, point being is, some people just assume that they are. I had a patient that assumed that he was taking vitamin D supplements. We tested his blood. He had toxic levels of vitamin D. Right? So he went to the far extreme. My point being is, take the test to find out if you're suspecting, if you're concerned. That's the only way. I don't care what anyone tells you. That's the best way. That's the safest way. This guy was toxic in his level, so obviously he stopped taking vitamin D3. All right. And there's been studies done, and I've read it. There's a study in France done. But the outcome is, if you have darker skin, darker toned skin, it takes longer for you to synthesize vitamin D3. Someone that has lighter skin tones, much like myself, it's quicker for us. And that's a genetic trait. Okay, it's just, you know, it's an adaptation to the environment and whatnot. Okay, so this is where it starts. All right, it starts here in the skin, and it eventually will wind up being produced in the kidneys in the active form as calcitriol. All right, and it helps to absorb calcium from your GI tract. Okay, it works in concert with parathyroid hormone, PTH. Okay, and that also will help to increase blood calcium levels. So calcitriol is a very important pro-hormone, all right, in the fact that it helps to increase your blood calcium levels. So when blood calcium levels are low, all right, you're going to see an increase in calcitriol levels. All right, another set of functions, secretion and absorption, okay? Obviously, we're going to secrete sweat. That's also going to help us to decrease our body temperatures. All right, so that is important, but also we talked about the different sweat glands, all right, the apocrine, merocrine, and then the holocrine glands. All right, we'll talk a little bit more in detail about the makeup of the sweat that you produce. All right, a lot of your sweat glands, all right, are going to produce the majority of the sweat that's produced will be water in certain sweat glands. Now we know, for example, holocrine glands, sebaceous glands are an example of holocrine glands. They produce sebum, okay? That's not so much, all right, for sweat. That secretion is to produce an oily secretion onto the hairs there, okay? But we'll get into that more. All right, when we talk about absorption, all right, if anyone here has ever tried to quit smoking, if they were a smoker and they tried the nicotine patch, bam. Fentanyl patches. My dog actually had to have a fentanyl patch because he broke his back. He was a year old, less than a year old. Got hit by a car, broke his bottom 2 vertebrae. Had surgery, they put 8 rods into his back, but that's a pretty painful experience. So they slapped a fentanyl patch on him and to help deal with the pain. Fentanyl is a synthetic opioid. And I want to say it's I say 1,000 times. It's about 1,000 times more potent than opium, okay? Synthetic, that's why they throw it in drugs. Anyways, so you use it on the skin, these patches here, because they are wonderfully permeable, all right, for absorption through the skin, okay? Very helpful. So we'll use that as a transdermal administration. Immune function, talked about that before, part of the innate immune system. That physical barrier there helps to keep things out, right? But also, when we were going through the layers of our epidermis, the outer skin layer, we talked about the dendritic cells, or the Langerhans cells, all right? And that's a special type of immune cell that just sits there in the skin, all right? And it monitors abnormal cell growth, but any type of pathogens that try to enter into the skin, and it will initiate the immune response there. Helps to really decrease cancer cell appearances. Because when it monitors an abnormal cell growth, it immediately attacks it and kills it. So it nips it in the bud right away, okay? So, and we'll talk more about that. Temperature regulation, again, you understand how that works with vasoconstriction and vasodilation. All right, blood is about 1 degree warmer than our normal body temperature. So normal body temperature is what? What's the magic number? 98.5, 98.6. Yeah, 98.6 is the normal number. So our blood will be a little bit warmer than that. Okay, so it'll be about 99. It floats between 99 and 100 degrees. Okay, so that's why when you're hot, you vasodilate. All right, the blood vessels in your skin. Blood rushes to the surface of your skin, and it lets the heat out. Now, when you're really cold, those blood vessels vasoconstrict, shunts the blood more towards the internal body cavities, all right, towards your organs, okay? You see that in hypothermia quite often. And so that will actually, that vasoconstriction there will pull the heat from the blood, it'll shunt it more towards the internal abdominal and thoracic cavities there, okay? So let's think of vasoconstriction will conserve heat, vasodilation will release the heat. And then, of course, we have a bunch of sensory receptors in our skin, all right, for innervation of stimuli detection, external stimuli detection, internal stimuli detection. All right, touch is mainly the primary type of sensory receptor that we'll see. But we have thermoreceptors there for temperature, okay? And we have pain receptors there, obviously, because if something's hurting us, we definitely want to move away from that stimuli. Okay. So let's review the layers of our skin, okay? The first two that are listed here are part of the skin, the epidermis and the dermis. The subcutaneous or the hypodermis is not part of the skin. But we just talk about it here only because, all right, it's in close connection to the integument. All right, so when we're dealing with the epidermis, we're mainly dealing with stratified squamous epithelium, okay? So it's safe to say that our epidermal layer is made up of epithelial tissue. So therefore, it's also safe to say that those cells in that layer are tightly packed, because that's a characteristic of epithelium, and they're avascular. So if you get a paper cut and it does not bleed, how deep did that cut go? Think about it. If we get into the dermis, there's blood vessels there. Okay, so if you cut yourself with a piece of paper and there's no blood, how far did we go? Only into the epidermis. That's right. You only went as far to the epidermis because the epidermis is avascular. Okay, so we didn't make it into the dermis because the dermis is the layer that has all the stuff in it. Glands, smooth muscle, hair follicles, all right, blood vessels, all that stuff is in the dermal layer. Okay. So the deeper layer is the dermis, and that primarily is made up of dense, irregular connective tissue. Okay? Now, there's two layers, and we'll break it down. Okay? The papillary layer is the smaller of the two. That has areolar connective tissue. That's that loose connective tissue. Okay? And then deeper to that, we'll have our reticular layer, and that's going to be the dense, irregular connective tissue. All right, then beneath our skin, we have our subcutaneous layer. All right, and that sits right underneath there. We also call it the hypodermis. All right, it is primarily made up of adipose and areolar connective tissue. Okay, star this. It's not part of the integumentary system. Seen that asked on tests. Don't be fooled. Okay? We got enough to talk about in the muscle chapter, so we're not going to talk about the subcutaneous layer there. We're going to talk about it here, because there's really not much to say about it. All right? Okay, questions so far? Are we moving at a pace that is fine? Too fast, too slow? Okay, good. Cool. All right, so here's a quick picture of our skin. We've seen this before. All right, so you're going to see all this different items here. Remember, skin is one of the organs of our body that has all 4 tissue types. It has epithelial tissue, it has connective tissue, it has muscle tissue, and it has nervous tissue. Okay, and we'll see all of that as we move through this chapter here. All right, let's talk about the epidermis, the outer layer. The predominant cell type in the epidermis is going to be the keratinocyte. So the majority of the epithelium there is going to be keratinized, stratified squamous epithelium. Keratin kills, okay? So if you see a cell that is keratinized, all right, or if it's said to be keratinized, then it doesn't have a nucleus, and all the organelles are dead. Okay? All right. So the epidermis has 5 layers, or what we call strata. So if we start with the deepest layer, that's number 1. That's the Stratum Basale, or Stratum Basale. Okay? And think of B, basal bottom. Okay? Bottommost layer. All right? It's only 1 cell layer thick. Then we have the Stratum Spinosum. And then the 3rd layer is the Stratum Granulosum. Now the 4th one that you see there, the Stratum Lucidum, we only see that in thick skin. All right, and we talked about this in lab. Thick skin is only present, all right, on the palms of our hands and the soles of our feet. That's it. That's the only place that you're going to see Stratum Lucidum. All right. Neither one of those places have hair, correct? Look at your palms. Look at your soles. There's no hair there. Okay, so you won't have any hair follicles beneath these layers here. Okay, and finally, the outermost layer is the Stratum Corneum. That's what I'm looking at when I'm looking at you, and that's what you're looking at when you're looking at me. Okay, so these first 3 layers have living cells in them. Okay, the keratinocytes are living. We'll see when we get into the Stratum Granulosum, that's when they start the process of keratinization, but they're still alive when that happens, okay? So the first 3 layers there, all those cells are living. Okay, let's jump in. Again, some of this, does this look pretty familiar from lab, right? We kind of talked about it. So I apologize if this bores you, but it's a nice review, because I'm sure a lot of your brains are probably full, all right, from studying if you haven't taken the test yet. Okay, so the first layer, the bottommost layer, I've seen this asked on tests. You need to know what it's also called. Okay, stratum germinativum and the stratum basal. I don't know really the difference. You spell one with an E, one without. Okay, but I've seen it asked a lot for that one. Okay, so as we know, all epithelial tissue sits on what we call the basement membrane. That's what BM stands for, not bowel movement, but basement membrane. Okay, the basement membrane is immediately adjacent to this layer of the epithelium. Okay, so it's one single layer, and it's been described as cuboidal, low columnar. Right? I've even heard it described as polyhagnal. Okay, but the point is that this epithelium is not squamous. Remember, when we name stratified epithelium, we always name it for what layer? The top, the apical. Right, the top layer. Okay, this is the bottom layer. Right? We don't name it after the bottom layer. Okay, so even though it looks cuboidal or what we call low columni or polyhagnal, all right, it could still, you have to look at the top layer. Okay, keep that always in mind. Okay, so there's 3 types. We've seen these all before. The keratinocytes, this is the one that is the most abundant. This is the guy that makes that killer protein. Okay, and then we have our melanocytes. That's what's going to make our melanin. Okay, and that's going to be used to help protect our DNA when it's exposed to ultraviolet radiation. And then finally, our tactile cells, or Merkel cells. All right, these are the ones that when there's pressure on these cells, they're going to release their neurotransmitter, all right, and immediately adjacent to that will be a receptor, a sensory receptor, all right, and that will actually send a signal to your sensory system, your nervous system, all right, about some sort of stimulus regarding touch. Okay, light touch specifically. Light touch is also defined as discriminative touch. Okay, there's some people that can they can feel. I have not been able to unless it's really obvious, but they said they can feel the raised print on paper. That's how sensitive they are. Okay, pretty cool. All right, so those are the 3 cell layer types: keratinocytes, all right, the melanocytes, and then the tactile cells. All right, we're going to talk about each one briefly here, okay, like we did in lab. Okay, the first one here is going to be the keratinocytes. Okay, so in this layer, all right, this is where we see in the stratum basale, right, these cells are just going to be dividing. Right? So where there was 1, there will be 2. One will stay in this layer, the other one will move superficially up into the stratum spinosum there. All right? So we refer to them as stem cells here. All right? But ultimately, these cells are going to make that keratin. That keratin is going to then strengthen the cell itself, all right, offering protection, support, okay, making the cell much more hardy. Especially if we're dealing with the skin in the thick layers, okay, we need to make sure that those layers there are very protective for the mechanical stress and the wear and tear that goes on, okay? Okay, so if anything, make sure that you know, all right, what keratin's all about, okay? It's a protein. It makes the skin overall, but the cell itself stronger. Okay? And then when we're dealing with the stratum basale, this is where we're going to see cells constantly dividing. All right? And they're making new cells. All right? So one of those 2 cells that divided are going to move upwards. The other one will stay in that layer to divide again. Okay. So the next cell is going to be our melanocytes. Okay? And their job is to make, all right, melanin, and they'll also store that melanin, all right, because when they're exposed to ultraviolet radiation, all right, then they will share that melanin with neighboring cells. Okay? So the stimulus, all right, for these cells, all right, to produce more and to share is going to be that ultraviolet radiation. Okay? So once it gets exposed, it will transfer, all right, the melanin through the melanosomes, all right, to the neighboring keratinocytes. And then those neighboring keratinocytes are going to take that melanin and just smear it all over the nucleus. It's like, have you ever seen, I'm almost embarrassed to say this, but I'm going to share it with you folks. It's all right. I'm watching a show called True Blood. Never watched it. It's on HBO. Has anyone ever seen it? Okay, don't start watching it. It's like one of those shows, and again, it's my opinion. It's a vampire show, I thought. Now it involves fairies and werewolves. Oh, it just got crazy. Well, anyways, there's a scene where one of the characters is running from these dogs, or cats, I think they are. And I think someone else is watching it. You've watched it? All right. I just started season 5. So it's one of those things I'm like, all right, I've invested this much time into it. I got to see if it gets better or if it gets worse. You know, it's just one of those things. And I'm sure that some of you have watched a movie before. You're like, this movie sucks. But I'm like, it's got to get better. All right. Well, anyways, this character's running from these werecats, and he smears mud all over his body to try to throw off the scent. And so it's similar. Like, that's what the nucleus does. It will cover itself to protect, all right, itself from the ultraviolet radiation. Well, like that character, he was protecting himself, all right, from, well, he was trying to mask his own scent, but he was throwing off the dog. He was trying to prevent the dogs from, or werecats from attacking him. It's even embarrassing to say that. Okay, so the last type of cell, all right, in our stratum basale is going to be the tactile cells. You need to know this name also, Merkel cells, okay? And they're touch receptors, okay? And that's all they do. So when the stimulus of touch occurs, all right, a little bit of pressure is put on these cells, they release their neurotransmitters, and those neurotransmitters will stimulate and activate a sensory receptor for touch that's nearby. And then it sends that information up to the central nervous system. And the exciting part is that you'll learn how all that works later on in the semester. You will be masters at that stuff, I'm hoping, okay? Okay, so there's not really too much about that. We'll talk more about the different types of sensory receptors in chapter 16, all right, at the end of the course, okay? All right, questions so far? No? All right, so it's a lot of review so far, all right? Let's move into the second layer here, all right? In this layer now, all right, the cells that were dividing in the stratum basale have now moved into, all right, one of them has moved into this layer here. All right, so we're seeing our keratinocytes here, and the daughter cell from the previous cell layer, all right, has moved into this layer here. Okay, so at this point, we're done dividing. So now, all right, it's like going off to school. All right, baby's born. Okay, now the baby has to grow up and form relationships with people. Well, that's what's going to happen here. Our baby cell, our daughter cell, is now going to go off to stratum spinosum school and form relations, all right, with the neighboring cells. And how does it do that? It makes these intracellular junctions. They're called desmosomes, okay? And they're basically where the plasma membrane of these cells kind of folds in on itself, and it's almost like if you were to sew, all right, two sheets together or whatever, okay? So these desmosomes create these tight junctions or these, how do I want to say it? Well, these adhesions. Okay, like if you staple two pieces of paper together, where the staple is, it's holding those two pieces of paper together. All right, where these desmosomes are, it's going to hold those cells together. All right, and so that helps to, one, densely pack the cells, but also so they're not shifting around on top of each other. Now we're seeing a new cell here. Okay, the Langerhans cells, or our dendritic cells. These are immune cells. Okay. And they're in both the stratum spinosum and the stratum granulosum, all right? So when we talk about they initiate the immune response, I'm not really going to get into that, but it's called APC. They present an antigen, and they show it to another cell that's part of the immune system, and then the immune system kicks into gear, okay? But this is what I love about them, all right? They phagocytize things. They do the Pac-Man thing. They go in and they find something, all right, and they gobble it up. If it's a foreign protein, a dangerous protein of some sort, part of a bacteria, part of a virus, then they'll break this thing up, and then they'll display parts of it on its outside. Right? That's kind of weird, but that's just what they do. Because then another cell from the immune system will come over and see that and be like, all right, let's see if this is normal. If it's not normal, if it's not good, then it'll initiate the immune response. Okay? But what they'll do is they'll gobble it up, and then they'll initiate the immune response if needed. Okay, so those are going to be your Langerhans cells or your dendritic cells. All right, they fall into a classification which is known as APC, antigen presenting cell. Macrophages do something very similar to that too. Okay. All right, so keep in mind desmosomes. We'll revisit desmosomes. You're going to see those later on. Well, we did. Wait, I'm sorry. I've already talked about desmosomes with you before. We were talking about the cardiac muscle cell. Remember the intercalated discs, those dark lines, all right, that you see in cardiac muscle tissue? Well, they're made up of two things. They're made up of desmosomes, so it holds the cardiac muscle cells together so they can get a much more efficient and forceful and effective contraction, all right? But with the intercalated disc, we also have gap junctions. Gap junctions are like holes in between. They punch holes in between the cells. All right, the third layer, the stratum granulosum, okay? It's not a very thick layer. It's only 3 to 5 cells thick, okay? But this is where you start keratinization. So this is where the cells will start to kill themselves off, okay? Some do it sooner than others. Some take a little bit longer, okay? But if you can't see a nucleus inside the cell, that cell is dead, okay? If you can't see the organelles, especially if you don't have organelles, if you don't have any organelles, all right, those cells really can't make anything. All right, red blood cells, for example, don't have a nucleus and they don't have organelles. They don't make anything. All right, they used to, all right, before they lost all the organelles and before the nucleus went away. Okay, so some cells you'll see, all right, if they don't have a nucleus or organelles, one, they're either dead, all right, or they're soon to be dead. Like platelets, they don't have a nucleus either. Okay. Okay. So you have to assume then that those cells are dead if you do not see the nucleus and the organelles. All right. Questions so far? I feel like I've talked about this before. We have a little bit, right? A little bit of review is always good. Okay. The fourth layer that's only present in thick skin. Again, it's not very, very thick. It's only 2 to 3 cells thick, okay? But where we see this is in thick skin, so that's the palms of our hands and the soles of our feet, okay? And it helps protect, all right, our tissues from ultraviolet radiation. And one of the things we do mention about it is during the process of keratinization, all right, we have this protein there called the lead-in, okay? It's translucent or clear, okay? And when we detect this protein, all right, we'll see, all right, that this cell is undergoing keratinization and it hasn't quite gotten to the complete process of keratinization, okay? It hasn't finished yet. All right, and that's the stratum lucidum. Only in thick skin. It's easy to get that confused. Okay, so keep that in mind. Thick skin only. All right, finally, our last cell layer is the stratum corneum. Okay, this is the biggest and thickest one. Okay, 20 to 30 cell layers thick. All right, but at this point, all the keratinocytes have finished the process of keratinization. So they're all dead. They're tightly packed, because they've locked each other into place through the desmosomes, right? So they're not budging here, okay? So at this point, all right, all the cells here are going to be considered non-living, okay? And it's taken a little bit of time to get there, all right? It takes about 2 weeks from the point of division in the stratum basale to reach this layer here. And then those skin cells will spend another 2 weeks in that layer there, depending on where the area is. It's on the bottom of your feet, not too long, okay, or the palms of your hand, okay? But the nice thing about this layer is that it offers, all right, in accordance with our protection function, all right, it's a very dry, inhospitable area of our body, okay? Certain bacteria, or I should say certain pathogens, don't like dry areas. Right? They're like moist, like fungus, for example. Okay? They're like moist areas. All right? Well, this is dry. So that's going to cause an issue for some of our microorganisms that want to live on there. Okay? And also, we'll see, in addition, remember sebum, okay? Sebum that gets produced from the Hollican glands or the sebaceous glands has antibacterial properties. So that gets secreted onto your skin. In addition to the skin being dry, it makes it a relatively hostile environment for certain microorganisms, which works for our benefit, okay? So that's it for the epidermis. Not too bad, right? Come see, come saw. Who here hasn't taken the test yet? Yeah, you're like me. I waited to the last minute. Yeah, I'm bad like that. Krista hasn't either? Oh, okay. Candace, yeah. Well, I hear you. Okay. Well, I give you all credit then for coming to class still and not skipping out. I got my other class, my other section, my 211, their test days today also. All right. So here you can see, and we saw this in lab, okay? You can see in our thick skin how much of the stratum corneum you have. You can even see right here this nice sweat duct traveling all the way, all right, from our dermis down in here, going all the way through our epidermis. Okay, you can see it on the drawing here. All right, a couple variations in the epidermis. There's three categories: how thick it is, the color, all right, and the skin markings. Okay, this is the exact same slide that we used in lab. Okay, so we'll start with the easiest, in my opinion: thick versus thin skin. All right, where do we find thick? Palms, in the soles, all right, of your feet, okay, along your toes, your fingers, all that. Okay, so it's going to have all 5 layers. But again, it won't have any hair. So if we have no hair, we won't have hair follicles. And then therefore, if we don't have hair follicles, we don't have sebaceous glands. Because that's where the sebaceous glands live, right on the hair follicle. All right, but we will have sweat glands. Okay? If you ever had a job interview that you were nervous about, there was a possibility that you probably had some sweaty hands. Okay? So we know that you have sweat glands there. Also, if you've ever been in an environment where it's really hot and you're wearing some non-breathable socks and shoes, your feet get sweaty. I've had that happen. Okay? So thick skin does have sweat glands. All right. So we know where the thick skin is, so thin skin's everywhere else. Okay? Head, face, back, arms, knees, okay, calves, all that, all those areas there. Except it does not have a stratum lucidum. Okay, so it only has 4 layers. 4 layers. But it has sweat glands, and it has hair follicles. Look on the back of your arm. Okay? And so therefore there's hair follicles, there's sebaceous glands. Okay? And that includes, by the way, when we talk about hair follicles, hair, that includes peach fuzz. You guys have heard the term peach fuzz, right? Yeah. Everybody. So now for men, when we grow a beard, all right, that hair, that's not the peach fuzz. All right, that's going to be that coarse terminal hair. Okay. So, but everybody has peach fuzz. Okay, so if you have that type of hair, you'll have hair follicles in that area there. Okay. Okay, so that's the first one. Let me show you a slide here between thick and thin. Okay, you can see a huge difference. Here's the stratum corneum in thick skin. Okay, 30 layers or so. Here it is in thin skin, not very much. Okay. All right, skin color. What gives us our skin color? Okay, 3 things listed here: hemoglobin. That's the oxygen-carrying protein in our red blood cells. Melanin, okay, that's going to give us our skin pigmentation because of the melanocytes and ultraviolet radiation and genetic makeup. And then keratin, which I talked about in lab, right, when I told you about my Oompa Loompa friend. Okay? So hemoglobin, right? Obviously, when you have oxygenated blood, okay, oxygenated blood means you have a high percentage of oxygen, all right, attached to the hemoglobin molecule, so that blood will appear red, okay? Just if you were to cut yourself, you're immediately exposing, even if that blood came from a vein, which in most cases it does, or capillaries, all right, even if it was deoxygenated, as soon as it is exposed to the atmosphere, it turns red, because the carbon dioxide flies off the hemoglobin and oxygen flies out. It's just the natural process of that occurring, okay? So because of this binding here, that's what gives blood its color, okay? All right, melanin comes from the ultraviolet radiation stimulation, all right? It's going to be that darker pigment there, all right? These factors play a huge role, okay? Hereditary and obviously your ultraviolet radiation exposure, okay? Depending on where you're living. Okay, I lived in the second cloudiest city in the country growing up. Seattle at the time was the cloudiest. Rochester, New York was the second cloudiest. I didn't get a lot of ultraviolet radiation exposure there. I played outside a lot, but I didn't, and back then, and this doesn't apply to the younger students here, but I don't remember my parents putting sunblock or suntan lotion on me a lot when I was a kid. We just didn't. We didn't know that. I mean, I put it on my kids like I'm a weirdo, you know, all the time. You know, are you going to be outside longer than 5 minutes? Here, let me rub this on you, you know, all right? So you see it a lot more because we now know, all right, the harmful effects of that, right? But so the two big, what's the word I want to use? The two big factors that influence our melanin production is going to be our genes, the hereditary, and then how much sun exposure you get, okay? So, and I talked about albinoism. That's the guy with the pasty white skin, the white hair, and the pink eyes. Yeah. Has anyone ever seen a picture? Okay. So basically, melanin gives our skin its skin color, but it also gives our hair its hair color, and it gives the iris, the colored part of our eyes, its color too. Okay. So without it, you have pink irises. All right. Keratin, okay, vitamin A, huge component, all right? But again, we see it a lot in certain foods, especially carrots, all right? And it's huge role. We'll talk a little bit about it when we're talking about vision, all right? But this is really important, reducing free radicals. Does anyone know what a free radical is? Yeah, I didn't know until, you know, you heard about it. You know, free radicals are bad, or take, what do they call, antioxidants. Wheat chocolate or pure dark chocolate is high in bioflavonoids, and that helps to decrease free radicals. Well, anyways, a free radical, imagine this, going into a china shop, a real nice glass china shop, and you bring in your 4-year-old that has a yo-yo, and they start swinging that yo-yo around their head. That's what a free radical is. It has one single electron in its valence shell. It swings around. It just rips through things. All right? So oxygen is a horrible free radical. Certain reactions, and if you get into nutrition and in some of the, not so much genetics, but certain biochemistries, you'll get into a little bit more. They talk about it a lot in nutrition. But oxygen can make some pretty nasty free radicals in your body. But don't worry about it because you have some kick-butt cells. The peroxisome, if you remember that cell organelle, all right, it actually will make hydrogen peroxide that will destroy free radicals. Your own body makes kind of like a diluted version of bleach, which is still, in my opinion, the best cleaner that you can get. Like when I clean my shower, I always make sure I get that Clorox spray with bleach in it. It works awesome. I'm telling you. That's what you should be cleaning with. Obviously not pure bleach. Don't do that. All right. All right. So here you can see how our melanocyte here is producing the melanin, and then it has these processes here, and it has these granules that it's producing, and it'll share, all right, the melanosomes here with neighboring cells, all right, and then it coats the nuclei nearby. Okay. The last part of our skin markings, of the variations for the epidermis, all right, is going to be the skin markings. And again, these are all familiar. We talked about the nevus, the mole here, all right? So this is the one that you have to keep an eye on. Normally it's benign, all right, the cells, no problems. But if they have excessive and repetitive exposure to ultraviolet radiation, they have the potential to go malignant, all right, or cancerous. And that's bad news, right? That's why folks have to go in usually, I don't know when it really starts, 50s, 60s, maybe 70s, to go see a dermatologist to have their mole check, okay? So we always want to keep an eye out and watch for malignancy. That's like a growth. If you're like, oh man, I've had this mole forever, and then you notice, you know, one day like that looks a little bit bigger, and then like a month or so passes, and you're like, wow, that's bigger. That's when you need to go and make sure, and hopefully it's not too late, you know. Freckles, okay, yellowish brown spots. They're going to be scattered throughout. All right, again, these are just localized areas, all right, where the melanocytes have figured out, I'm going to just do my job, you know. I'm going to just make some melanin, okay. So a lot of it is going to be hereditary, okay. Like much for myself, I have freckles, but in the summertime when I'm outside more, they get a little bit darker, and when I say they grow a little bit, they're a little bit more numerous, all right, and that's because of the sun exposure, okay. But for the most part, like right now when you see me, all right, the freckles I have are based on my hereditary or my genes. Mangiomas, okay, benign, very important that you know that's a benign blood vessel tumor. They vary in size, they vary in location, all right. Most often when you see them in younger people, children, okay, they will be benign, and usually they'll go away. All right, larger ones might have to be removed, all right, through surgery, okay? But it's one of those kind of wait and see types of things. Friction ridges, all right, that is going to be our fingerprints. Remember, you have your epidermal ridges, and that's the part of the epidermis that just goes down like that. And then we have our dermal papillae, and that's the part of the dermis that goes up. Okay? These guys. And where they interlock with one another, okay, they're going to form, all right, this interlocking pattern with one another, which causes our fingerprints to occur, all right? But they help with creating friction, okay? I find it fascinating about certain things. I mean, I think that's cool that if anyone's ever seen the original Spider-Man movie back with Tobey Maguire, he's learning how to climb walls, and the camera zooms in on his fingers, and these little kind of, I don't know, they look like little claw-like things that come out that help him to be able to stick, that increases his friction. Your fingerprints do that, right? They help with creating friction, all right? I was trying to explain to my Bio 211 class, we were talking about the heart, and you have these structures in your atria and in your ventricles that are like rugae, okay? They're like a rugae type of thing. And that's important to have because they're called trabeculae carnae. And if you were to take your hands, have you ever done this and done that with your hands and kind of make that noise, that squeaky noise? Well, that's because you're creating a suction. Well, that's bad to happen in your heart, okay? You don't want to have a suction in your heart when the heart's beating, contracting, and relaxing, okay? Because the only time the heart should work is when it's contracting, all right? But if you have a suction going on, then you have to work to pull it apart. Well, your heart has decided to have these ridges in there, this trabecular carnae, okay? So it doesn't have that smooth surface there, so it can't create suction. So the point being is your body finds these little ways to make, you know, these actual anatomical structures serve a physiological purpose. There's more on that later, but I'm just saying. That was a little kind of tease for next semester. All right, we've seen that picture here. Let's kick out of that. Let's get into the dermis here. Okay? All right, so the outer layer is the epidermis. Now we're going to go deeper, and we're going to go talk about the dermis here. Okay? So, do you remember connective tissue proper? I'm a nerd when it comes to this, all right? So remember, connective tissue comes from this type of tissue. Finish the sentence for me. Oh, come on, quickly before I finish. Mesenchyme? Yes, mesenchyme. All right, think of mesenchyme as embryonic connective tissue, okay? So mesenchyme has three choices of what it wants to turn into, okay? It can turn into this guy here. I'll just draw the line over there. Connective tissue proper, okay? Or it can turn into, finish the word. Supporting, yes. Okay? And then the third is fluid. Nice. Okay. So we know now our three types of connective tissue, which we should have known anyways. Okay? Connective tissue proper, right? Supportive connective tissue and fluid connective tissue. So connective tissue proper has two types. Do you remember the two types? Well, now you're going real specific. Go more broad. Loose. And what's the other one? Dense. There you go. There you go. Okay. And then we can break down the dense into the dense regular, dense irregular. All right. So my point being is, think of the connective tissue as having all the stuff. Okay. That layer has all the stuff here. So if you look here, okay, we saw in the epidermis we had the epithelial tissue. There's still three other tissues that were due. Okay, here's our sensory, so that's our nerve tissue. Here's the erector pili, that's our muscle. And then we have our connective tissue, all right, which is dense irregular connective tissue, is the predominant type of connective tissue in the dermis here. All right, but look at all the other stuff we have in here. blood vessels, sweat glands, sebaceous glands, hair follicles, nail roots. Okay, so we're going to find all the stuff, all right, of our skin is going to be in the dermis. We have two layers, the papillary and the reticular. Our papillary layer is the smaller of the two. Okay, the reticular is going to be the thicker. Papillary is superficial. The reticular layer is going to be deeper. Okay, so the predominant type of connective tissue in the papillary layer is areolar. That's a loose connective tissue. And one of the characteristics about loose connective tissue is that it has a lot of ground substance. And ground substance is free space, essentially. So therefore, we're going to put into that free space blood vessels. Why not? Okay, it makes it good. So in this layer here, all right, we have those dermal projections, or what we call dermal papillae. You saw those when I drew in these little bumps here, all right? And that's where we'll have some sensory receptors, we'll have blood capillaries in there, okay? And it's this dermal papillae that interlocks with the epidermal ridges to make those friction ridges, or our fingerprints, okay? All right, the deeper layer, the reticular layer, the larger of the two, it's predominantly made up of dense, irregular connective tissue. Now again, dense, irregular connective tissue has less ground substance than loose connective tissue, okay? But out of the dense connective tissues, all right, this one has more ground substance than the other two. So there's a little bit more space in there. So it's going to be a little bit more vascularized. Remember, dense regular connective tissue are ligaments and tendons. They don't have, all right, a lot of room for blood vessels, okay? But dense irregular connective tissue does. So we'll see blood vessels in, all right, this reticular layer also. Okay, keep in mind, it is deep to the papillary layer. All right, good so far? Okay. We'll skip that. We've already seen that. Okay. I'm going to skip this because we already talked about this, the lines of cleavage and all that. Let's get into the subcutaneous layer, also known as the hypodermis, okay, referred to as the superficial fascia, which is kind of funny because we used to think that the superficial fascia was garbage when we were dissecting bodies, but we're finding more and more that it has a certain role. I'll talk more about that later on when we get into muscles, okay? But first things first, let's review. It is not part of the integument, okay? I know I keep saying this, but every semester people walk out of my classroom still thinking it is. So I have a goal. I won't change that goal. All right, so subcutaneous layer, the two connective tissues, which are both loose, areolar and adipose, which means it has a pretty high level of vascularity, which is good. Because remember, the functions of adipose tissue, energy storage, cushioning, insulation, well, guess what? All right, if you're storing energy in that tissue and you need that to mobilize that energy, you best have a way to get that energy to places throughout your body. How do we do that? Circulatory system. All right, and the more of it we have in this type of tissue, all right, the better it serves its purpose there. Okay? All right, so we'd like to give drugs here to this area because of all the blood vessels there. Highly absorptive. All right, muscles the same thing. A lot of blood vessels will go to muscles. All right, so you'll notice that sometimes you might get a shot, and I think I've talked about it, I think it was with this class, I don't know if it was this section, about the COVID shot, but people have complained that, you know, with the COVID shot that they're getting soreness around the injection site. And I just read an article today. Has anyone gotten their COVID shots? Okay. Did anyone tell you not to take Tylenol, acetaminophen, or anything, or ibuprofen before you get it? Did they do? Okay, good. All right. I just wanted to make sure. It's interesting about that because I don't think I've ever been told, whenever I've gotten any type of vaccination, not to take any of the painkillers or anti-inflammatories. Because believe it or not, I had someone tell me that yesterday. Okay, good, yeah. And I was talking to a patient about it yesterday also. and they were saying that they were told that they shouldn't be taking Motrin. They said Motrin specifically, but they didn't say anything about acetaminophen or. But anyways, I happened to come across that article. I was like, well, that explains it. Okay, what time are we looking at? Oh, we're making great time. Great time. I'm going to quickly run through nails. I know we did it in lab, okay? But I want to kind of quickly just review, all right, the nails here. All right, I won't spend as much time on it as we did in lab. Again, when we're dealing with our nails, both toenails and fingernails, all right, that is the outer epidermal layer, the stratum corneum there, okay? Keep in mind, all right, the purpose and function of the nails to protect the ends of our toes and fingers, all right, and they're also going to help in picking things up, okay? All right, so these first three terms here, free edge, nail body, and the nail root, these all make up the nail plates. I think I gave you the example, if you were to smash your finger and your nail falls off, that's your nail plate. All right, and that's made up of all three of those. The free edge is the part you cut off. Okay, so it's hanging literally off the end of your toe or your finger, so there's no capillaries underneath, so that's why it looks white. Okay, the nail body will have capillaries underneath it, so it'll almost have, I'm looking at mine right now, should be pink, okay, underneath there. All right, and then the part that you can't see because it's embedded into the skin is the nail root. Okay, then underneath the actual nail plate is the nail bed. And that is made up of living epidermis. I can't say that enough, okay, because those cells are alive, so then those cells don't have what inside of them? What kills? Keratin. Okay, keep that in mind. Okay, that is made up of living epidermis. If it was dead, it'd have keratin. Okay? All right, so this all looks familiar, right? Let me just show you this on a picture. Come right back. All right, so this is what we're talking about. Okay, here's our free nail, our free edge. All right, and then we've got our nail body, and we can't see the root here underneath. All right, but we can see it on this one here. All right, so there's the free nail edge, here's the body, and then here's the root. All of this, all right, is the plate. And then underneath here, all right, that is going to be the nail bed. That's our living epidermis there. Good so far? Okay, all right, again, this is review, I know. Which makes me feel good because I know that you guys are going to kick butt on the test then. The next test. This is not on the first test, by the way. All right, I don't want anyone to get nervous. This is Chapter 6. Chapter 6, Chapter 7, and Chapter 9 are in Lecture Test 2. Okay? Okay. Just want to remind everybody. Some people get nervous. Okay. All right, so a couple other parts of the nail here. All right. When we were learning about the hair itself, we were talking about the hair bulb and whatnot, and we had the hair matrix. Well, here we have the nail matrix. This is the part that is going to be growing our nail. Okay? It is going to be growing, and it's proximal. So we all know the term proximal. Why is that not working? I think it froze. Yeah, what is it, 7:04? Yep, pretty much. Give me 1 second. Sometimes it'll, let me try something here. Yep, of course. Of course. Give me 1 second while you guys talk amongst yourselves. Are you folks with me? you guys hear me at home? Okay, all right. It froze on me again. Okay. Cool. All right, good. Okay, so where was I? Okay, so we talked about the matrix there. Again, it's at the it grows. It's located in the proximal portion. All right, and we all know what that means. In relation to our finger, the proximal portion is going to be towards our elbow or wrist. Okay, and then the distal portion is going to be towards your fingertip. Okay, so then if you notice on the nail here, you have this white portion here. Okay, that's the lanula. All right, and that is a thickened region. All right, of the tissue there. All right, and so that's why it appears white. Okay, it's very thick, so we can't get the underlying capillaries to show through. Okay, and then on either side of our nail, all right, we have the nail folds. That's where the skin is folding on top of the nail. And then our epiconium or the cuticle, all right, that is where we're going to see part of the epidermis kind of move on to the nail itself. And then finally, the hypoconium is where the free nail edge hangs over our fingertip. Okay, I'm going to come right back to the slide here. Okay, so here are a couple of things. All right, here's the cuticle. All right, the epiconium right here. And then if we go down here, here's the hypoconium, this little area right here, where the free nail edge hangs over the end of your finger there. Okay, let's go back. All right, questions about that? I know the fingernails aren't terribly exciting. All right. I forgot someone was telling me there's this place and they do foot massages, but they don't do manicures. And my brother-in-law goes and he says it's incredible and it's relatively inexpensive. And they massage like your foot and ankle. I want to say it's on Wade Hampton. I would recommend it. I've never gone, but from what he says, it's awesome. Oh, all right. So let's talk about some nail disorders because I have not talked about that with you folks. Okay. So a couple types of nail disorders real quick. All right. And there's more out there than what's just listed here. All right. But it's another tool that we can use to help, all right, determine how healthy somebody is just by looking at their nails. All right, perfect example, we're talking about brittle nails. If someone has brittle nails, all right, usually, okay, think about it. If you make a house out of garbage material, it's not going to be a very structurally sound house, right? You're not going to make, not to say that balsa wood isn't good wood, but it's not a good wood to use to build a house, all right? So when we see brittle nails, all right, a lot of us are thinking, all right, in some sort of situation, you either have poor circulation, all right, or you're malnourished, okay? So you will see literally on the nail itself, okay, you will see these lines, all right, just splits, okay? And you will see literally layers of the nail. If I'm looking at it from the side, that's a horrible drawing, but that's supposed to be the nail. It's like a claw, all right? You'll start to get layers of the nail peeling back. Okay, ingrown nails, I'm not going to ask. I have to fight the urge to ask people. All right, but if you ever had an ingrown nail, you know that it sucks. All right, it's bad. And basically, the nail starts to just dig as it's growing. It grows into the skin. If it gets really bad and get infected, and then you can have all sorts of issues. There's ways to deal with it, but the best way to do it is don't wear shoes that are too tight and cut your nails regularly. All right, onychomycosis. Fungal infection. All right, these are a bear to take care of. When I say take care of, in most cases you have to go on medication for at least, and when I've talked to podiatrists about it, because they see it obviously all the time, at least 12 months. To really get it licked, a good 12 months you have to. So it's a real pain in the rear end. But because think about it, one, blood supply down to the toes, it's so distal, it's so far away. And so you need to circulate the medication constantly through there. And fungus is real tough to get rid of. All right, yellow nail syndrome, okay? So when we see a thickening here, all right, and the growth of those of the nail tissue, all right, when we start to see a reduction. Again, that could be several causes. A lot of times it's going to be malnutrition, right? That's going to cause that. All right, spoon nails, very interesting. And when you see spoon nails, that's when the nail itself becomes more concave, all right, kind of like that. All right, so here's your finger. It's pretty bad. Okay, so it indents inward like that. Okay, yeah, right. And so some of that can be cardiovascular in nature. Bowes lines, all right, you'll see these right in the nail itself. You can tell when the nail stopped growing temporarily. It could be because it was damaged somehow, stress. Again, I keep bringing up malnutrition, but it does happen. Vertical ridging is not to be confused with clubbing. Sometimes people will confuse that. All right, vertical ridges, all right, if you look, you might have some. All right, I check. Every time I teach it, I check, and I have some vertical ridging there. All right, and it's no big deal. It's just somehow, you know, again, when we talk about the vertical ridges, go up to this picture here, and you'll see where I drew those lines will just be kind of a ridge formation in some of the nails there. All right, I'm going to stop here because we're moving along at a pretty good pace, and it just seems like a good place to stop. So let's take a break for about 15 minutes or so, and we will meet back and do lab. Question? No. All right. All right. If you folks at home have any questions, just ask me in lab. All right. I'm signing off.